Hey, so this is page 67. This is about resolving vectors. So these are talking about situations where you have a diagonal vector and you know the magnitude and the direction, but you might want to change it back so that you know the individual I and j components. So let's have a little read of this example. We've got a vector, the magnitude is 10, and it makes an angle of 60 degrees with the I direction. Okay, let's plot that roughly. So we've got an arrow. Let's just put it sort of up this way. It makes an angle of 60 degrees with the I direction. So I would be the horizontal, like this. That is I there. So we've got an angle of 60 degrees over here. We also know the magnitude of this vector. So the length of this section here, that is 10. And we're going to use trig to find the adjacent and opposite sides. So yeah, this is classic trig really. We're just piggybacking off those ideas from GCSE maths. It's nothing new. So we know a hypotenuse, we know an angle, and we're looking to find the adjacent and the opposite. So if I think about SOHCAHTOA, the information I have is I know the hypotenuse, and for the adjacent, well, that's A, isn't it? So I have A and H. I'll use cos to do that. So formula for cos is cos theta is the adjacent over the hypotenuse. I know the angle is 60. I know the adjacent. Oh, sorry, I don't know the adjacent. That's unknown at the moment. And the hypotenuse is 10. And if I rearrange this formula a little bit, I'm going to take the 10 up and multiply it by cos 60. Make some space as well. So I will have 10 times cos 60 as my adjacent. If I type in 10 cos 60 on the calculator, I'm going to get an answer of 5. There we go. So I've managed to find the adjacent there. Similarly, if I use trig to find the opposite, I'm going to use the hypotenuse and I want to find the opposite, so I'll use sine. Sine theta is the opposite over the hypotenuse. I know the angle is 60. The opposite, I don't know yet. The hypotenuse is 10. I'll multiply both sides by 10 to bring it up. And the opposite is going to be equal to 10 sine 60. Which in exact form is 5 root 3. And as an approximation, it's about 8.66. There we go, lovely. So let's just highlight those. There we go, I'll use the exact value actually. So in vector form, the horizontal part is 5, so it's going 5 units across. It's 5i. And the vertical part is 5 root 3j. Nice. Let's have a look at another example, one that's a little bit more nuanced again.